Welcome to Mrs. De Castro's chemistry class. So today's lesson is still on covalent bonding. So this is the second part of the lecture on covalent bonding. So just to recall, we said covalent bonding is the sharing of electrons between two nonmetals. So these are your keywords. You have sharing of electrons, and then you have two or more nonmetals. Okay, sharing electrons to become stable. How do they become stable? Again, they have to conform to the octet rule. Now, just to recall, we had as example hydrogen, which becomes stable by sharing one pair of electrons with another hydrogen atom. We had oxygen, which becomes stable by sharing two pairs of electrons with another oxygen atom. We had nitrogen, which shares three pairs of electrons with another nitrogen atom to become stable. And also, we had water, wherein each hydrogen atom becomes stable by sharing a pair of electrons with an oxygen atom. And we said this is how we come up with the formula H2O. Right? So today we will look at other examples of covalent compounds. All right. Now, one of the important compounds in chemistry class is what we call the carbon compounds, and this makes up a branch of chemistry in itself, which we call the organic compounds. So today, let us look at carbon, and let us look at how it shares electrons with other atoms to become stable. If you look at your periodic table, all right, carbon has 6 electrons in its outermost shell. If you look at its electronic configuration, it is 1s2, 2s2, 2p4. So you see that carbon, 2p2. So you see that carbon has 4 valence electrons, and to become stable, it needs another 4 electrons. So how does it get these 4 electrons? Mainly by sharing with other atoms. So if I were to draw the carbon atom, you would have the nucleus with 6 protons and 6 neutrons. You would have your 2 electron shells. All right, the first shell has 2 electrons, and the next shell has 4 electrons. Now, for our purposes today, let me draw these electrons this way. Okay, so putting this into Lewis symbol, I would have carbon, right, with 4 electrons like this, wherein the symbol represents the nucleus and the inner electron shell, or I can also draw that carbon in this way to show that it needs 4 electrons to become stable. So by way of a model, your carbon atom would be this one. All right, so you have the carbon atom with 4, showing you that it needs 4 electrons to become stable. Right, so let's say carbon shares electrons with hydrogen. And we have looked earlier that, or we have seen earlier that hydrogen can be represented like this, right? And for hydrogen to become stable, it needs to share 1 electron. So if carbon and hydrogen were to share electrons together, we will come up with something like this. Okay, let me just redraw this for you. So you would have carbon with 4 electrons here. Okay, let's have hydrogen. All right, and I will put, okay, each hydrogen can only share 1 pair of electrons. So the only way it can share electrons with carbon is to have 4 hydrogen atoms. So what is this showing you? It's showing you that this hydrogen atom is now stable because it has 2 electrons in its outermost shell. So, and that is true for each of the hydrogen atoms. And now look at carbon. Carbon will now be stable also because now it has 8 electrons in its outermost shell. So class, we can redraw this into this model where you have the carbon and then it is sharing one pair of electron with each hydrogen atom, and we can represent that by this model. All right, so we can represent that by this model. So you have the carbon with your 4 hydrogen atoms. All right, so how did carbon become stable again? It had to share a pair of electrons with 4 hydrogen atoms. Why 4? Because each hydrogen atom can only share 1 electron, right? So that is for your carbon with 4 hydrogens, sharing electrons with 4 hydrogens. And class, we call this compound, there's a name for it, we call it methane, right? So carbon plus 4 hydrogens, okay, and the formula for this will be CH4, okay? So CH4, methane, that's carbon sharing a pair of electrons with 4 hydrogen atoms. Okay, let's look at another example. Now this time, let us consider the possibility of carbon sharing electrons with both itself, carbon, and hydrogen. So let me try to redraw these 4 valence electrons of carbon in this way. I can redraw carbon, so I have the 2 valence electrons, and I can have the other 2 here, right? So that's carbon with its 4 valence electrons. Let me just draw another carbon atom here, all right? So I will still have 2 electrons, and I will also have the 2 valence electrons. So notice that these carbon atoms can share these 2 pairs of electrons, and still they will need, all right, another pair of electrons to become, another 2 pairs of electrons to become stable. So let me bring in hydrogen. All right, so let's say I have hydrogen, okay, here with 1 electron, another hydrogen atom here with 1 electron. So hydrogen with 1 electron and hydrogen with 1 electron. How can these 6 atoms share electrons so that at the end all of them will become stable? So class, look at this. This hydrogen will share a pair of electrons with this carbon, and so with this hydrogen, and this hydrogen. And this carbon here will also share this pair of electrons, 2 pairs of electrons with carbon together with hydrogen. So in the end, this carbon is going to have this structure, right? All right, so if I do that, notice that this carbon will now have 2, 4, 6, 8 electrons. It is stable. This carbon is going to share 2, 4, 6, 8 electrons, so that now it is also stable. Redrawing this, I can have this carbon with a double bond with another carbon atom and a single bond with each hydrogen atom. So if I were to show this to you by way of a model, I would have this carbon atom, all right? So this is your carbon atom. This is the other carbon atom. So we have here our hydrogen atoms, all right? So we have the 4 hydrogen atoms, and if they all come together, we would have a compound like this one. All right, so this is now our compound. So notice that is actually our carbon, all right, double bond with another carbon, and you have a single bond with each of the hydrogen atoms, right? So this is that compound, and we can actually redraw this into your C, okay, if we see H2, CH2, or we can actually combine this together, and we say it is 2 carbons with 4 hydrogens. All right, so there is a double bond between them, and the name of this compound is ethene. All right, so what is ethene? It is a carbon double bonded to another carbon atom, and then you have 4 hydrogen atoms around it. Okay, so what is the reason for that again? We want each of the atoms to become stable, and they can do that by, all right, the carbon atom sharing 2 pairs of electrons between them, and each hydrogen atom sharing 1 pair of electron with each carbon atom. All right, let's look at one more example. So this is an example where you have a double bond and a single bond in the same compound. All right, let's look at another example.